All right, so the next topic will be IP version 6 and 4. Yeah, so we will be looking into what is 4, IP version 4 and IP version 6, and we will be doing some comparison between these two. Before that, let me quickly introduce to you, run through some of the slides that we have done on Friday. Uh, the internet and network layer 3, yeah, in your TCP/IP model. As we have covered on Friday, the function of TCP/IP model includes to define the datagram. Either it's going to be UDP or TCP, right? And then defining the internet addressing scheme. Either it's going to be on version 4 or version 6. And then we also look at how data is being moved between the network access layer and transport layer, the layer next in the higher ranking, yeah, after network layer. And also we will look into some what we call fragmentation and reassembly of datagrams. And the last, almost the last topic is the routing datagram to remote hosts. IP, we have covered this in quite detail through the discussion that we had on Friday. Basically, you need to discuss TCP and IP separately, yeah? Because TCP is reliable, IP is unreliable service. Both takes place at network layer, and as what we have covered last week, routing of packet or packet switching happening at networking layer as well. And IP itself, Internet Protocol itself, is unreliable. Of course, the system will try to deliver the data in the best effort or delivery mechanism, comes with some recovery from lost packet, which will be done at the higher level. Yeah, especially under TCP/IP, where we have covered the handshake, yeah, three ways handshake arrangement or mechanism from the sender to the receiver and vice versa. And also we have covered connectionless delivery mode using UDP, yeah, or through wireless, to make it simple, through wireless, where packets are delivered or routed either through circuit switch or packet switching independently. Reason, remember, under the packet switching that we have covered, it doesn't really dependent or depending on the channels. It could be three different routes or three different channels. And once the packets arrive at the destination, these packets will be reorganized or rearranged accordingly, according to the details inside the header and trailer. All right, so that's the reason why it is written there can be delivered out of order, because in your header there is information for each packet, the sequence of the packet, and there are a lot of other details as what we have seen inside the header, the details inside the header for each layer or each uh, delivery. So resequence will be done at the higher layer before it is being passed to the lower layer. IP4 is still used as of today, which all of you are very familiar with. And we are moving into version 6 and also some devices already running on version 6, which is 128 bits. So this is version 4. Remember, I told you this slide is quite important. All of you have to remember the details inside the IP4 header. There was one question, I think 1 or 2 years ago, they asked you to draw this and then they asked you to label it and explain. Of course, if it is an open exam or take-home exam, you will not run into any problems. You can always refer to this slide or to your any other resources in order to answer If it is a closed book exam, then you have to memorize all these. You have to explain one by one. What is version? What is IHL? What is differentiated services, and so on. Try to understand each one, the details or the fields inside the header, and most importantly is the size of the IP version 4, which is a 32 bits length compared to version 6. So remember all these details, yeah? Time to leave, protocol, fragment offset, header checksum, that's for the error checking. Then we are moving on to IP version 6, where it happens after 1990s. The reason why we come out or we change from version 4 to version 6 due to many reasons. Main reasons are due to security and the running out of version 4. That was the main reason, because we have many more devices or things, Internet of Things today compared to what IP4 can support. So IP version 6, like what we have seen last week, if you use the formula 2 to the power of n minus 1, it will be running into billions of hosts or billions of uh, client server. And of course, IP version 6, it is much more simpler compared to version 4. Reduced routing table size, simple protocol, better security. It covers better type of service compared to 4, version 4. It helps in multicasting. Yeah, that means you can do multiple or different types of casting, broadcasting at the same time. Roaming will be better without changing the address between version 4 or version 6. Future protocol evaluation is built in, and of course, it will also support any new protocol that we might have over the internet or over any other platform in the future. All right. So we have seen all these details last week. So I'll run through quickly. I don't want to so-called go into the details and take much time, because all these are quite simple and you guys have covered this in many different subjects. We also have done this comparing between the packet headers and between version 4 and version 6. Remember the length, important, the number of bits, and the details inside the header, both the headers. IP version 6 extension headers, meaning what are the additional things in IP version 6, such as hop by hop option, yeah, from router to router, hopping from router to router, that is built in version 6. Destination option is built in, routing details is built in, allows fragmentation, authentication, and encryption. All these are built in into version 6. Some of these features are not in version 4. IP addressing, again, very basic information that we have covered in many different subjects and levels. Uh, Basically referring to your IP address version 4 or version 6. Yeah. And more devices are being migrated from version 4 to version 6. And also, if we can see, we will see the format of version 6, so that you are, yeah, at least know what is version 6 instead of just version 4. So this is version 4, 32 bits, all in 1 and 0, grouped into 4 8-bit octet, and each octet is represented by decimal number from 0 to 255. Right? You can divide this 32 into 4. You will get each section 4 bits, which will make up one of the IP address. As you all know, the IP address consists of 4 numbers, isn't it? For example, like what you see down here, 172.24.0.0. So each one of these is built up of or make up of 8 bits of 1 and 0. And the numbers is range from 0 to 255. Yeah, like what you see here. 4 decimal numbers are separated by periods in a format called dotted decimal notation, like this. 1, 2, 3, 4. Now that is one IP address. The other IP address is again another 4 octet or decimal numbers, 1 and 0 into decimal numbers. Yeah? There was one question, you will see that in the past year exam paper. They ask you to convert from binary to decimal, decimal to binary. Even though it is very easy, student unable to do it. Student unable to do it. So please take note. There will be such a simple question as that. This is another example. We replace each group of 8 bits with its equivalent decimal number. So you have to migrate. Yeah. So that equivalent to 129.11.11.239. How you calculate 239, for example, you start from here, right? Yeah, you start from here 1, 2, 4, 8, 16, 32, 64, and 128. So you total it up. Yeah, if 0, you don't count. Now, if 1, you count. That's it. So you will get these numbers. Another example. Okay, and another example. There are 3 examples for you here. How to convert binary to decimal and vice versa. Again, same. The other way around. Okay, IP version 4, I think we shouldn't have any problem. Let's take a look at IP version 6. They are not compatible. There will be some communication issue, but there are many devices, modern devices are supporting both. IP version 6 are specified in hexadecimal format. In version 4, it's not hexa, it's octet. So in version 6, we have 16-bit section because it's based on 16-bit format. And it uses total of 128 bits, meaning double of IP version 4. 8 groups of 16 bits. Yeah, in version 4, 4 groups of 8 bits. 4 groups of 8 bits. Over here, 8 groups of 16 bits. They make it double, they make it double. Can't do broadcasting. Version 6 can't do broadcasting but can do multicasting. Yeah, there is a difference between broadcasting and multicasting. Multicasting, for example, you can specify which address you want to do broadcasting, which address you want to do non-broadcasting or reliable, dedicated connection-based broadcasting or connection. In IP version 4, you can just broadcast to all the addresses. Example of converting IP version 4 into version 6, you got to have 1, 2, 3, 4, 5, 6, and in fact more of, remember 8 group, isn't it? You got to have 8 group of 16 bits each. And it's not machine read, I mean human being readable. Like what you see here, it's quite long. This is version 6, all in hexadecimal. So you might not understand. You might not understand unless you convert it into binary, hexadecimal into binary, 16 bits, and then you convert back into decimal. So the address will be quite, if you look at it, it will be quite confusing. And it is not intended for human being to read because anyway it is in what we call hexadecimal format. But the machine can understand it better, easier for the machine. Reason the machine that we have today is all 32 bits or 64 bits, which is very powerful. So 16-bit is not an issue. It's not an issue for the devices that we have today. Example, change the following IP version 6 addresses from longhand notation to binary. So you have to convert. Yeah, you have to convert, make it 8 group first. So here you have 1, 2, 3, 4, 5, 6, 6 groups only. So you got to make it 8 groups. So where are the missing? In between here, right? In between here. So 2001, year one, this so-called one, what we call number of bits are missing. So you add on a 0 here, make it DB8, and then here 8583, and then they put a dot, dot, dot. That means there are missing bits over here. Then you continue with 8A2E, 0, 370, you add on with 0 to make it 16 bits. 7, then follows with 7334. So you have 1, 2, 3, 4, 5, 6. So missing 2 groups. So you add on the 2 groups over here to make it all zeros. So this is a complete IP version 6. This is an incomplete IP version 6. This is longhand. So we wanted a complete version 6, IP version 6. So you insert zeros wherever the zeros are missing. Okay, the other difference between IP version 4 and 6, we may not pay attention, is in version 4, you use single dot over here. In version 6, you use colon, colon, double dot, not single dot. So also pay attention to that, because sometimes, because it's too easy, we might overlook. Then you ended up putting a single dot, which is wrong. It got to be double dot. Yeah, example. There are more examples down there. So what you need to do is you need to convert each one of this number to binary. Binary. For example, this 2. See, they convert this 2 further. 2 into 2. This is 2. 0, yeah. Sorry, 1, 2, 4, 8. So this is 2. This is 0 over here 0. This is 0 over here 0. This is 1 over here is 1. This is 0 over here is 0. This is D. Remember, D is equivalent to, in hexadecimal, it goes to 9, 10 is, A is 10, 11, 12, 13, and 14. So you convert that accordingly. D over here. And then this is B. And then this is 8. 1, 2, 4, 8. And this is 8. So you do that, and then you will get the entire so-called 8 group. 1, 2, 3, 4, 5, 6, 7, and 8. So this is how you convert from longhand notation to binary notation. Yeah. So this is longhand notation to binary notation. Any question? So now, so in an exam, I remember I told you guys there was one question to convert IP version 4 to IP address, sorry, version 4 to binary, and also version 6 to binary and vice versa. It's quite easy, but also easy to make mistake. So do it correctly, do it carefully. IP version 4 versus 6, more examples. Yeah, more examples, 4 octet versus 16 octet. Examples, more examples. Okay, next we're going to go into few classes of IP addresses. But mainly this refers to IP version 4 rather than version 6. So IP addresses can be categorized into few classes A to E, but the common one is ABC. D, E, and F, D and E have other function or purpose. So the important ones are A, B, C. In fact, you have covered all this in your diploma, so I will not go through into very detail, just to refresh you. So in class A is, as you can see, the first diagram, 24 bits, and then 8 bits is for the class A, for the host, and for the network, and the rest for the host. 24 bits for the host and 8 bits for the network. Class A, as what we have covered during the normal classes, class A normally will be whole or will be assigned to big players like Google, Microsoft, IBM, and most of the companies are in US, the pioneer companies, and they are the what we call suppliers, ISP. They hold this class A. Normally we don't get, hardly we can get it today. All taken up by the big players. For example, Cisco, cable TV, AT&T cable TV, Microsoft, IBM, Oracle, all the big players, where they have hundreds or thousands of hosts around the world, but they have very less clients. Very less clients. How you calculate the number of hosts is very easy. You use the formula 2 to the power of n. So over here for class A, the number of hosts can be 2 to the power of 24. Number of client or network can be 2 to the number of 8. Not many. This is in one network, just one network. But if you have more network, you can always have more. Class B is 16 and 16. Again, class B also is quite difficult, also holds by the big players. Whoever do not manage to apply or obtain class A will go for class B. 2 to the power of 16 number of hosts, 2 to the power of 16 number of network. And class C is the common one. And most of the Malaysian companies and all of us are in class C, where the number of hosts are 8, number of networks are 24. What it means, not this, what we call 32 bits is not for the entire world, it's for one network. For example, let's say UOG is having their own network. In UOG, if they go for class C, then they can have 2 to the power of 8 number of hosts. 2 to the power of 8, 128, which is a lot. I don't think so. UOG will have 128 hosts, isn't it? Or servers. The most they might have. Those days we used to have 100 of servers long, because we used to run one service in one host, in one server. But today with cloud computing, with VMware, all kind of virtual world, we are running multiple OS and multiple services on a single box. So our footprint has been reduced very much. Today you can have even 5 servers, high-end servers, to run all the services that you used to run on 100 servers. So with that, you need less IP address, less footprint, less physical servers, but definitely it got to be high-end, more powerful servers. So if you take class C, for example, UOG can just use class C for the entire worldwide operation, where they can have 128 number of hosts or servers, and they can have huge number of clients, which is 2 to the power of 20, uh, 24, 2 to the power of 24, minus 1, normally, because you start with 0, minus 1. So that is more than enough for any network, either Lazada or Shopee or IBM. But of course, the big players, like I mentioned earlier, they will have class A and B. But if you set up a new company, for example, Grab, Grab will not get A or B because we are running out of IP addresses. Grab might get a C, and then Grab can have 2 to the power of 8 number of hosts, which is more than enough, and then number of clients, 2 to the power of 24, which is more than enough. And of course, later you will cover that. Beside this class A, B, and C, which are for large, medium, and small network, we also can have our own private IP addresses, which does not come under this what we call class A, B, and C, or D and E. So in fact, you have more flexibility to use your private IP addresses instead of using public IP addresses. So next, what you see in your slides, basically the class A up to class E with the number of IP addresses as well as number of bits, and also the range of IP addresses that each class represent, and number of hosts and number of networks that each class can have, which I already mentioned to you earlier. If you use the formula 2 to the power of n, class A can have 16 million plus 16 million plus number of hosts. Give me a minute. I'm using Wi-Fi now. 1 million. Okay, guys, sorry, run into some network issue. All of you can hear me, yeah? If you cannot hear me, let me know. Can I continue? Sometimes,
Yes, sir.
yeah, sometimes it worries me. There are 40, 50 people, and I don't know whether you're with me or not. Sometimes we got to do like what we used to do when we do marketing. Are you with me? Type yes. Are you?
Yes.
Yes.
If I do that, I think all of you will be with me. Otherwise, I'll be doing lecturing here, and then some of you will be sleeping, comfortably on your sofa set. Okay, fine. I hope all of you are with me, following me. If you have any questions, you can either type on the message. So far, I don't see anything. All right. Just one
Can I speak
advice,
instead?
lah. What is that? Anything?
Can I speak instead of typing?
Can. All right. Let me continue. If you have anything, please stop me. It's already 4 plus. Anyone need a break? No, isn't it?
Uh, can. Yes.
You want a break?
On.
You want a break? Can take a 5 minutes break. No problem.
Sure. Thanks.
Okay. Take a 5 minute break. I'll see you all at 4:15. 4:15. Okay. take a 5 minutes break. You need to go to a loo or take a quick drink or whatever it is. Go ahead.